In this video, we're going to learn to represent ratios in multiple ways. Represent the following scenarios as ratios in the indicated ways, then determine if the comparison is part to part or whole part to whole. So let's read through the problem and highlight important information. In Martha's math class, there were 8 students that passed a test for every 2 students that failed a test. Write the following ratios for the situation using the given numbers, and then write a simplified ratio. Notice, so that was our goal. We're going to write the ratios, and notice it says include units in each of your answers, and we're also going to write the corresponding simplified ratio. Okay, so there's 3 ways that we represent ratios. In this course, most frequently we're going to use the fraction expression, but we also use colons. You'll see that a lot when you see odds for something, maybe the odds of getting a disease or of winning a prize. And we also use this A to B language, the ratio of 5 to 7. So we're going to practice writing all of these and using units and a simplified version. So ratio of students who passed to students who failed. Okay, so when we're asked for a ratio, the first value is the value that goes in the numerator for a fraction. So we're going to write, now the units are students, but I'm going to write passed here. So 8 passed for every 2 who failed. Now, I highly suggest that when you write your ratios in these problems, you include what they're representing. Okay, so officially with ratios, if the units are the same, this is students to students, the units actually cancel out, but the passed and failed quantities are going to help you remember which each number corresponds to, and it's going to help us solve problems later. Okay. So now we can simplify this. 8 over 2 is equivalent to 4 over 1, or just 4. Okay. Now let's use the colon notation. So we would write 8 passed, colon, 2 failed. Okay. And we can simplify this just like we simplified the fraction. This is equivalent to a fraction, so you can think of dividing both quantities by 2, and 4 passed for every 1 that failed. Okay, and notice that's equivalent to our fraction 4. A to B language, we would write this as 8 passed to 2 that failed, or we might just say 8 to 2. Okay. So again, use the units and descriptions, but we can simplify this a little bit more, and this would also simplify to 4 to 1. Okay. So notice in the fraction expression we may simplify this just to the whole number 4, but since it's representing a multiplicative comparison of 2 quantities, the implied number in the denominator is 1. Okay. Now we're going to write the ratio of students who failed to the students who passed. So basically this is just reversing the direction. So 2 failed for the 8 that passed. And notice if we simplify this, dividing by 2, our ratio is 1 over 4, or 1/4. Notice this is just the reciprocal, and that makes sense because we just reverse the places in the numbers and what place they go into. For colon notation, we'd use 2 failed, colon, 8 passed, which is equivalent to 1 student failing for every 4 students that passed. And finally, A to B language, we would say 2 failed to the 8 that passed, which is 2 to 8, or also simplified 1 to 4. Okay? So notice when we're writing these ratios, we don't know how many students are in Martha's class. There could be 1,000, or there could just be 10 and 2 students failed and 8 students passed. There could be 5 students, 1 failed and 4 passed, but this ratio is giving us information about the total number of students without actually knowing the total number of students. We're getting that multiplicative comparison. And now we're asked, are the ratios in the table a part-whole comparison or a part-part comparison? Explain. Okay, so a part-whole comparison is when you have a whole where the part is part of the whole. Okay, that sounded like a mouthful. But the whole in this case would be all of the students in the class. Okay, so the students in the class are made up of students who passed and students who failed. Those are the two things you can do. So the whole would be all students. And the different parts we can look at are the students who failed or passed. And notice in each case, our ratios didn't include the total number of students. We were comparing the number who failed to the number who passed in each case. So this is a two-part experiment comparison. Let's look at another example. We're going to highlight the important information. In Cedric's fish tank, there were 6 blue fish and 9 yellow fish. Write the following ratios for the situation using the given numbers. So we're going to, just like last time, write the ratios. We're also going to write a simplified ratio, and we're going to include units in each of our answers. Okay. So here we're asked for the ratio of blue fish to the total number of fish. Okay. Well, there are 6 blue fish, and the total number of fish would be including both the blue and the yellow, okay, because it said there were just blue fish and yellow fish. So 6 blue over this as a total, and that would be 6 to 15. Okay. Now we can simplify this. These each have a factor of 3, so we could also write this as 2 to 5. So there's 2 blue fish for every 5 total fish in the tank. Using the colon notation, we would write this as 6 blue fish to 15 total fish. Okay. And we can simplify by dividing these by 3, just like we did in the last case. So there's 2 blue fish for every 5 total fish. And finally, A to B language, that would be 6 blue to 15 total fish, or, oops, divided wrong, 2 blue to 5 total fish. And again, in this language, we'd usually just write 2 to 5, okay? But again, I want you to include these units for your reference for later problems. Now we're going to compare the ratio of yellow fish to total fish. Well, there are 9 yellow, and we already found that the total number of fish is 15. So now simplifying, common factor of 3, we have 3 yellow fish for every 5 total fish, or 3/5. Using colon language, we have 9 yellow, colon 15 total. Dividing by 3 gives us 3 yellow for every 5 total number of fish. Okay. And finally, A to B language, we have 9 yellow to every 15 total fish, or equivalently 3 yellow to every 5 total fish. Okay, so notice again, when we say total, it doesn't necessarily mean the total number of fish. We know that Cedric's tank, we're assuming that there were only blue and yellow fish here, so the total is 15. There weren't any other colors. Okay, but when we're referring to the total within the ratio, we're comparing, basically the total is referring to the whole of the comparison. So that comes to our next question. Are the ratios in the table a part whole comparison or a part par comparison? Explain. Well, the whole in this case would be what we could say total fish, or you could think of it as all the fish in the tank, or you could think of both colors. Okay, so the two colors combined gave us the total number of fish, and a part would be either color fish. So notice in both cases we compared a part, either blue or yellow fish, to the total number of fish. So this is a part whole comparison.